recording has just begun. Hi again, everyone, and welcome to the day 3 of our webinar series. And today's topic is meshing in CENOS RF. So once again, we are recording these meetings, and you will be able to rewatch them later on YouTube. And yeah, so the topics for today is just a basic overview of the meshing inside CENOS RF, and basically the benefits of having an automatic meshing solution, and basically just how you could adjust the mesh manually as well if it's not to your liking. And we'll also be covering how to validate your mesh based on your results, and also some basic meshing limitations will also be seen as well. So before we even start off, what even is meshing? So since CENOS is a frequency domain solver, we rely on the finite element method to calculate the processes that happen in and around our antenna. So using something called the mesh is necessary. And the meshing is basically the process of dividing our model into a simpler object, such as a tetrahedron, into many of these small tetrahedrons to calculate the processes in these small little triangles. And basically that is just what meshing is. And yeah, so basically the finer the model, the finer the mesh you have, the more accurate results you will get. However, there is a limit to this where you can basically decrease the element size of your mesh, but it will not net you more accurate results. But it will give you a much larger calculation time, which grows exponentially the larger mesh size you have. So mesh optimization is an essential part of simulations, as you'll see. And as you can see in this image, we have a rather beautiful example of a very bad mesh. There, where the patch is an extremely rough mesh. And on the right side, you can see also an example of a bad mesh where the mesh is extremely fine. So ideally, we want to see something that we can see on the right-hand side, where the substrate itself has a smaller element size, larger element size, excuse me, and smaller element size inside the conductive parts. But yeah, in CENOS, this is done automatically. And we use NetGen for this, which is a tool that is available. And as I said, the mesh consists of these small little tetrahedrons, 3D volumes, to simplify the calculation process. And typically, this is done seamlessly in the background when you define your model, the roles of the model and the physical settings, and you just press run, and it does this in the background. But in cases where you want to mesh the model a little bit more finely, you can adjust this manually in the mesh generation screen. So what are the benefits of the automatic mesh? So the automatic mesh removes the needs, or it basically saves you time, and it'll help you basically, in most cases, forget about meshing, and in cases it removes the possibility of seeing something that can be seen on the right-hand side in the image, where the mesh is extremely coarse, and you would lose a lot of the accuracy. But basically just decreases the initial case setup time and helps you understand where you can actually do some manual adjustments should they be needed. And basically our end goal of the presentation today is to understand how the meshing works in CENOS and learn how to use the different mesh density options that you have once you have generated the primary mesh. And if these do not provide the result that you were hoping for, I'll be showing you how to adjust the mesh manually using submesh face and edge refinement, which has been made incredibly easy and straightforward to do in CENOS. And some basic tips on how to actually choose a good mesh element size. And finally, how to understand how to validate your own mesh using the results. So without further ado, let's jump right into it. So let me stop presenting, and I'll open up the presentation of the app itself. So first off, let's take a look at the automatic mesh that gets generated once you press run. So first of all, this is the model that we'll be working with initially. This is the same model that we created on our first day of the RF webinar series, the IFA antenna, and everything has been already set up. And let's go into the mesh generation. So right now we haven't generated any kind of mesh, but if I were to press run right now, it would generate the mesh in the background of the simulation. But you can also generate the primary mesh and see how it looks right now. So let's press calculate mesh, and it's going to apply the automatic meshing parameters based on the roles that you have applied in the role application screen. And as you can see, we already have a mesh of our pretty basic model already done. As you can see, our IFA arm has been meshed a lot more finely than the surrounding objects. And since we would see some E-field distribution around the edge of the ground plane, that has been also refined a little bit more finely than the rest of the model. So in case you think that this model is a bit too coarse or too fine, in this case, it's actually perfectly good, except for the substrate around here. You can change the mesh density. So currently, it's always set as the preset to be average. But if you want to run a quick validation simulation, you can select rough and recalculate the mesh, and that should provide you a rougher model than you had before. So as you can see, it did get a little bit rougher. And you can also choose fine, and in this case, it'll make the mesh a lot more finer. And as you can see, the calculation time also increases, the mesh calculation time also increases the finer the mesh you choose. So let's go back to the average mesh, and let's take a look at what kind of parameters that our automatic mesher has chosen for this model. So to enable the manual mesh settings, you have to disable the automatic meshing on the button here. And we are greeted by the submesh selection screen. So right now, our submesh for the air domain has been disabled automatically, so it doesn't obscure the visibility of the overall model. As you can see, we can enable that just as easily as well. But let's take a look at what kind of refinements the automatic mesher did. And to do this, since we are working with a model where the conductive parts are 2D surfaces attached to the substrate, you'll see the refinements that were done inside the submesh to which the faces were attached to. So solid 1, which is the substrate, we click on that, and we should be able to see the element edge length for the overall submesh. So everything that's not defined a specific role, such as a patch or ground, will not be meshed any differently than the rest of the substrate. And on the bottom, we can see the table of the refinements that were done automatically for the faces and the edges. So if we hover over these, we will see which face it actually pertains to. So if I hover over face 8, we can see that face 8 is actually just the IFA arm. And same goes for the ground. And since we are working with some sort of edge refinement, we can also hover over these faces. Let me pan around. And we can also hover over these edges and see the edges that were refined as well. And yeah, so I can start working with this model, but instead I will be showing you how to adjust the mesh with an extreme example I have already removed all the manual parameters, automatic meshing parameters as well. So as you can see, this is the model that we saw before in the presentation, where the model is extremely roughly meshed. And let's mesh this to be actually a lot better. So let's start off by going into the substrate role. And let's start off with some face refinements. So in order to do some face refinements in our model, we just have to select the face that we want to mesh more finely. So let's select the IFA arm. And once we do that, we can see that the face that we selected appears in the submesh um, uh, refinement tab. And it automatically gets applied the element size of the substrate itself. But here we can actually just change the value to anything that we want and press accept and then recalculate the mesh. And as you can see, it changed the element size here. So let's choose something a bit smaller. So as you can see, the problem with this approach is that I am sort of going in semi-blindly. So this is another benefit of the automatic mesh. So if I open up the other model that we saw before, I can already see the parameters that were used by the automatic mesher. And so if I think that this IFA arm is a bit too fine, I can just adjust the parameter and make it a bit rougher. So I'll change the element size to be, for example, 0.3, press enter and recalculate, and I can easily just make incremental adjustments. So in this case, this is a bit too rough, but that's what the automatic mesher is for. So we don't have to work with that so much. So as you can see, we have done this refinement, but I also want the substrate to be a little bit finer. So I'll decrease the element edge length and recalculate the mesh, and we should be able to see the changes being done here on the left side. So right now I've only shown you the face refinement, but edge refinement is also completely doable, and all we have to do some edge refinement is select the edge refinement tool button, and now we can select the edges in the model itself. So let's select this edge and all the other edges that we had defined beforehand. So let's do it like that. And basically, we have selected all these edges, but again, they're applied the same element edge length that the submesh had. So another handy tool is that we can change the size for all these elements at the same time. So let's change it to 0.4, apply that, and all the element sizes for the selected edges will be applied to that value as well. And let's recalculate the mesh, and we can see some refinements. So let's choose 0.2 here again. And basically what we have done is what the automatic mesher has did in the other model already. So as you can see, we have pretty much made the same case that we did before. So yeah, so this is a really basic case. So let's open up something a little bit more complicated. So here we have a directional coupler which contains multiple solids for each and every coaxial connector that we have here. So we have the outer conductor, the dielectric, the inner conductors. And the thing about how I set up this case is that if we go back to the role application screen, I defined all the conductors into a single role, all the outer conductors and all the inner conductors. So as you can see, if I highlight the conductor 2, you'll see that all of the inner conductors get highlighted. Same goes for the dielectrics and the conductors. And why I'm bringing this up is that instead of selecting a specific element size for each and every of these domains, solids, I can adjust them in one go if I select them in a single roll. So as you can see, also in here, if I highlight the conductor 1, all of the other conductors of the coaxial connectors also get highlighted. Same goes for the dielectric and the inner conductors and the substrate. So if I want to refine the dielectric in one go, I can just assign some value, recalculate the mesh, and it's going to apply that value for all of these conductors at the same time. But in this case, I might have applied a bit too rough of too fine of an element. And in case you have done something wrong, the mesh troubleshooter may uh, uh, start troubleshooting the mesh that you just created. But in this case, I'm going to cancel that as that's not really necessary at this point. But yeah, let me think if I have forgotten something. I guess not. So basically, I'm going to open up the floor for any kind of questions that you might have. So feel free to ask any questions at this point, and we'll try to cover them. So think of this as the interactive part of the webinar. Are there any questions? So if everything was completely understood, you can always reach out to us at our support email, and here the email is. And those of you who have the ability to, you can always reach out to us through the support chat and ask any questions that you might have regarding the meshing or anything else. But yeah, please, if you have any questions, go ahead and ask them right now. Yes, Nick, go ahead.
Yeah, so this is off topic. I hope you don't mind. But on the new version, we've lost the accepted power graph, which was, is it possible to get that back?
The graph has been removed to make way for the S parameter phase, but you can get the accepted power of the antenna in the CSV export. So I don't think I have a similar case here, but yeah, here it is. So if you open up the CSV export, you'll be able to see the accepted power of the antenna here as well, but you will have to plot the graph yourself in this case.
Okay, thank you very much. Thank you. It's just that that's what I've been using for my comparisons of different models, and so I've lost my comparison now. Okay, thank you very much.
No problem. So I see that we have a question in the comments. So Steve asked, are there many cases where a model won't mesh, but doing some manual adjustments will allow it to complete the meshing, or is it generally something that needs to be done on the geometry level? So in most cases that we have worked with, the automatic mesher works completely fine. And oh yeah, apologies on my side. I completely forgot about a single part of the demonstration is the validation of your mesh. So once you have simulated your case, so this is the rough model that we had before, you can validate your mesh by basically just looking at the electric field distribution at your frequency of choice. So as you can see, we have these large, rough, jagged edges in the E-field distribution. And this is generally not a good thing because you're losing some resolution in your calculation. And to perform some validation of how finally you should be meshing your model, or in case the automatic mesher has not done a good enough job, you can take a look in here and see these jagged edges. And if you want to see how the mesh looks inside ParaView, you can enable the visualization by selecting the object you want to validate the mesh on. So in this case, it'll be the solid one, which is the substrate. You will have to click on the electric field distribution window here. As you might see that it has like a blue outline on the outside. And then you'll have to select surface with edges on the top. And as you can see, we can see the same exact mesh that we saw beforehand in the mesh generation screen. So if you can see that there are large objects where there is some E-field distribution, you might have to perform some manual mesh refinement. And that is exactly what we did. Apologies. That is exactly what we did in this case. So basically, if I remove all these refinements again, we can see that if we take a look back inside ParaView, we can see that we need some refinement to be done around these parts. But if I do some refinements on this face here, it should also affect the mesh around it as well. So we should be getting some finer mesh around it as well. And as you can see, there's some distribution of the E-field around the edge of the ground plane as well, along the straight edge. So then we can also enable the edge refinement and select the edges that we need to refine as well. So basically apply 0.4 for everything again, and we should be good to go. So let me select a single frequency for this so we can actually take a look at how it changes. It will have to be recalculated since the start frequency is the frequency that gets taken into account when generating the air size. And yeah, let's change the element size to something a little bit smaller. And let's quickly run this case. All right. Looks like I have to close the results. And we should be able to see the results of our changes. Unfortunately, I did overwrite the results that we saw before, but we can see that the E-field will change quite a bit in the visualization. So generally, the process is if you see these jagged edges, and you should take a look at your mesh and validate how it looks. So as you can see, we no longer have these extremely jagged edges. There could use some extra refinement as well, but as you can see, it's mostly concentrated around the lines of the IFA itself. And that's how you can validate your mesh. Hopefully I answered your question, Steve. So if you can give me a heads up if I did or did not, please let me know. Okay, great. Steve says, yep, thanks. So any other questions? So if there aren't any other questions, basically, thank you for listening. And please, if you have any other additional questions, something that we might have not covered here today, you can go ahead and send us an email over at rf-support@cenos-platform.com. Hopefully that email is correct, but it should be. So thank you for joining us today, and tune in next week when we'll be covering phased array simulations in CENOS and how to use your CAD files in CENOS as well. So thank you again, and see you next week.